Okay, with part D, which is the tough part, we are still working with that dv dt that is 2. So we know dv dt. And we want the rate of change in the area of this triangle. So I moved the triangle down from the picture that we had up at the top so that we could see it. So we want dA dt. So that means for step 2, we need to write a relationship between A and V. So we know that triangle's areas are 1/2 the base times the height. So if we come back here and look here, this will be our base and this will be our height. Our goal is to get the base and the height in terms of V, because we want A connected to V. If we look at B, it is a horizontal distance, so that means it's a difference between horizontal coordinates. So this particular base here would be a U minus a V. But we did, up in part A, we made a relationship between U and V, and U is actually the same as 3/2 V. So that means this base is in reality a 1/2 of a V. By the same token, we can figure out what the height is. The height of the triangle is a vertical distance, so it will be a difference between y coordinates. So I can take the top y minus the bottom y and get a 1/v squared minus a 0. So now if I simplify this, I see on top I have a 1, a v, and a 1. And on the bottom I have a 4v squared. I can reduce that and get a 1/4v. So I figured out now that the area is 1/4v. And step 2 is to take the derivative of that. Now I have a lot of people who mess up the derivative of that. For some reason they forget to do the chain rule or they do something funky. So what we're going to do is we're going to rewrite this a as a constant times a power of v, because we'll make fewer mistakes if we do that. So that means my area is a 1/4 v to the -1. And in step 3, I'm going to take the derivative of that on both sides with respect to t. So on the left, I would just get a dA dt. On the right, I will move through the constant, and then I'll hit the power, which would be a -1 v to the -2, and then I'll hit the v, dv dt. If I now plug in the instantaneous information from step 4, which is v is going to be 8 and dv dt is 2, then I can rewrite and plug in dA dt is 1/4 times a -1/v squared times a dv dt. So if I multiply this out and reduce it, the 2 can cancel with the 4, and I'll get a -1 on top and a 2 times a 64, or a 128 on the bottom. Because it's area, I will have units squared, and the rate is still over t, which is measured in seconds. So my final step is to interpret what this means. So at the instant in question, A is decreasing, since that rate was negative, at a rate of 1/128 units squared per second. And we're done.